Hello everyone, again we are back with another question, sliding window maximum. So this question logic is straight up very simple. The first solution, that is, I would say, n cross n solution, the big O of n square, that is also easy. It can be figured out. But the optimized one is a little tricky. So I'll just quickly explain the question. So here we take this example. There is a nums given, and we are given a window 3. So let's say 3 is the window which is given. So in each of the window that can be created over that list or the array, we have to basically find the maximum. So for the first array, for the first window, that is 1 3 and minus 1, from this 1 3 and till here, till this minus 1, the maximum is 3, so we add 3. From the second window, it starts from 3 minus 1 3, so we again add 3. Then the third window is minus 1 minus 3 5, the maximum is 5, so we add 5. Similarly, in the next window it will be 5. In the next window the maximum will be 6. In the last window the maximum will be 7. So basically we have to create the list of all these maximums in all the windows, and we have to return it. So I will explain it with a simple solution, with a simple approach which I initially created. So the approach is quite straightforward. What we have to do is we have to we have to create a temporary list. Okay, we'll name it temp. So as soon as we'll run a loop for I equals over the length of nums. I will not run it up till end. I'll let you know why. But currently just imagine there is a loop running from I for I from 0 to over the length of nums. So initially in the temp within that loop we'll initialize temp with nums of I. So nums of I is, let's say, 1. So initially nums of 0 is initially 1. We can see it as 1, so we add 1 over here. Now what we are doing is we'll iterate in the within that loop, within this for loop, we'll create another loop for j that iterates over the k. So what we do is we create a window, we create an initial window of 3, and we see the maximum. So temp has currently 1. So we see, and when we go to second, j equals to 1, from j equals to 0, since it is already equal to temp, the last element of temp, so we are not going to do anything. So, and we also create a answer list over here. So so we don't do anything, and then we see 3, that is j of 0. So we see that let's say we have, let's quickly have a look of how we managed it here. Yeah, so what we do is we do temp equals to max of temp and max of temp and nums of j I plus j. So basically it's like in this window, whatever is the base address, upon that we are appending j, and we are trying to see whether it is greater than the current value of temp or not. So current, initially, since we initialized it with 1, we are reiterating j over this window. So we are seeing whether 1 is greater than 1 initially, since I equals to 0 and j will also be equal to 0. So 0 plus 0 is 0. So we'll see whether I is greater than the last element temp. So yeah, I equals to 0. For I equals to 0, it is equal, 1 equals to 1. So we don't do anything. But when j goes in the inner loop, when j goes to second element, that is 3, then we search, then we again run this code, temp equals to max of temp and max of temp and nums of I plus j. We do this and we see that 3 is greater than 1. So we also get in the temp becomes 3. And then we come to minus 1. Since minus 1 is not greater than the current value of temp, that is 3, hence temp remains 3. Now there is a catch, like when do we start appending to answer. So let's say, okay, we not consider this. Let's say we have a answer list which will return at the end. So once I or let's say when once I has reached the or every time we'll be basically appending every time for every I we have to append the answer to attempt to the answer. So we see that in the first window, since the inner loop has ended, the for j equals to over the k has ended. So we might have found in the first window we have found what is the greatest element. So in the first window we found that greatest element is 3. That is what we have initialized temp to, or we have stored in temp. So we'll just simply add 3 over here. Now next up what we'll do is we'll increment I. Since this loop is ended, we increment I. Then again we initialize temp with I. So I, since this time I is 1, I equals to 1, temp equals to nums of I. So that means temp is initialized to the second element. Second element is 3. So temp equals to 3. Now again in the inner loop we will, so there's one thing over here. What we are doing is we are doing like every time I is incremented. For the first time when I was 0, we created the whole, we ran the whole loop over k. But second time when I has incremented, so there are few elements that are common. So for example, 3 and -1 are common. So we are not going to touch them. What we are simply going to do, we are simply going to see that whether the current element which is seen, the current new element which is seen this time will be -3. So whether -3 is greater than what was already appended to answer, because this is the new element. So if it is already greater than whatever was the maximum in the previous window, then anyways we have to simply add it, right? But because let's say if it is 6, okay, so the new element which we are seeing is 6, and the element which was maximum in the previous window was something less than 6. So naturally we'll add the 6 value over here, right? So if it is greater, we simply add it and we move forward. If it is not greater, then then there are two conditions. So let's say the new element which is coming, the nums of um let's say the nums of I plus k, I plus k minus 1 it would be. Since the new element which is coming in the current window, it is not greater than the already value which is present in answer, then what we do is we see whether the element which is leaving, this element was leaving, right? Since this is a new window, we are not considering 1 over here, we are considering this window. Okay, I will mark it with red. Maybe we are considering this window now. So 3 minus 1 minus 3. So the element which is leaving is the first element, that is 1. So since 1 is being left, so we just simply see whether 1 is equal to the previous maximum. So basically we are seeing whether in the previous window, whatever was the maximum, is it leaving when we are seeing the new window. If it is leaving, then again we simply run a loop over this these three elements, and we find the maximum and we append it. Okay, but so the case is same. So we see first condition was whether the new element that is coming, is it greater than the current element which is added to answer. No, it is not. So we don't do that, we don't append it. Now we see whether the element which is leaving, that is 1, was it the greater element in the previous window. No, it was not. Okay, so if since it was not, we can simply repeat the element which was greater in the previous window. Okay, now once the I again increments, so we are here, we the next window which we are considering is, maybe I'll use a different color for this. So what could be a different color? Yeah, maroon. Hope these are the elements now. Now again we'll see whether 5, the new element which is coming, is it greater than the already maximum in the previous. Yeah, it is greater, so we simply add these things. Okay, add this particular variable. This is simple because in the previous element, previous window, 3 was maximum, so no matter what, will not get any value which is greater than 3. Since the new element is already greater than 3, so we simply add that element. Simple as that. Now we go to the next window. We come to this window. Now we see whether 3, the current coming value, is it greater than the previous maximum? No. Then we see whether the leaving, the element which is leaving, that was -1, is it the one is it the one which was the maximum in the previous window? No, it was 5. So since both of the conditions are not true, so we simply add 5. We repeat it. Now we come to this particular section, 536. Now we see whether 6, which is new value which is coming, is it greater than the previous maximum? Yeah, we simply add it. We go to the next window. We see whether, say, the new element which is coming, 7, is it greater than the previous maximum? Yeah, it is greater than 6, so we simply add it. So what would have happened at, let's say, if it was not greater? So it was like, let's say, 5, and the value which was leaving, the element which was leaving, that was 5 was leaving. 5 was something less than, like, 5 is anyways the value which is uh, okay, so 5 is the value which was the previous maximum. Okay, it was the previous maximum. So basically, in the new window, we are leaving the previous maximum. So what we would have done, we would have iterated over 3, 6, 5, or whatever is the this particular window. We would have required to iterate over this window to find the new maximum. So we see that there are few loops within this loop. So we see that this is the solution which I have commented. So we see that there are few loops within the loops. If the window is quite large, like let's say somewhere near to n, so it will become, the solution will be of the size n comma n into n into n, that is n square, or we can say it is n into k. So in the worst case, it is n into k. So this was getting out of time complexity, and we also have to notice in this scenario we are not running uh, I loop till the end. We are running it till nums minus k plus 1, because I reached till 3. I reached till 3 over here, and the window was completed. The last window was anyways visited, so we didn't have to run it completely up till end. So that was one thing. Now, what is the optimized solution? This optimized solution is actually very interesting. We basically used a doubly double-ended queue. So how did we do that? Well, it's actually quite interesting. I was able to figure out the solution. Uh, Yeah, but it took me quite some time for that. So I will -3, 5, 3, 6, 7. It is, yep, 0 to 7. Yeah, we'll just simply name or give the index to these elements for 1, 2, 3, 4, 5, 6, 7. Now we create a queue, and the answer, where's my cursor? Yeah, we, okay, we create a queue. So what we do in this queue, there are simple rules. When the queue is empty, if the queue is empty, we simply add the index of the first element. Since it was empty, we added it. Now, the next element, when the next element comes, we see whether this element is greater than what was the element at the index, which is already present in queue. So the index here is 0. So element at 0 is 1. So 3 is greater than 1. If the coming element is greater than the element at the given index, then we pop this. We remove it, and we simply add the index of the coming element. So 1 is the index that is added. But if the coming element, the next element, is smaller than what is present in the starting of queue, or from the last we are checking, so whatever is present in the last of the queue, if it is smaller, if the element that is coming is smaller, then the element at the index at the last of the queue, then we simply add the index of the coming element. So we add 2. Since -1 was smaller than 3, that's why we add 2. Now I'll let you know why we do this. So first of all, let's follow the process. So 2 is added. Now -3. -3 is even smaller than -1. So we'll also simply add the index of -3, that is 3. But yeah, there was one thing. So we saw that first window was formed when we reached k. Okay, so when we reached k, or we can say when three elements are seen, k is equal to 3, we know when three elements are seen. So we have formed the first window, right? We have formed the first window. So basically we have to add one answer to the answer list as well. So we will have a condition that if I equals to k minus 1, if it is the case, then we simply add the value uh, that is at the start of the queue, the element that is at the index of the start of the queue. So now we understand why every time we see a bigger element, we are we are popping the elements from the start of queue. The reason is we want the start of the queue to have the maximum element. Okay, it should always have the maximum element in this queue. So since we see at the start of the element we have 1, so you will see the index 1 will have the maximum element 3. So till now in the first window also 3 is the maximum element, and when we reached I equals to 2, even then 3 was maximum element. When we reached I equals to 3, even then uh, 3 was maximum element. But we'll start appending to answer list only when I has reached up till 2, because that's when the first window has been seen. So I has been reached to k minus 1 when I is will not put equal to, will put greater than. Whenever I is greater than equal to k minus 1, we'll put the first greater element. The first greater element is 3. Since this is the, we'll take it from the index, the first index of q, so it is 1. So we just simply add 3 over here. Now now next up we have 5. So 5 is coming in. So 5, we see the element 5 is greater than -3. Okay, so we have to also, one more thing. So we have to see that 5, the index of 5 is outside the window of what was initially appended. So 1 and 5, five's index is 4, so index of 5 is 4. So 4 and 1 cannot lie in one window. Basically 3 and 5 cannot lie in one window because the window size itself is just 3. Okay, so whenever we see that the coming element has index which is greater than, which minus which, like let's say the coming index is I, so I minus whatever is at the start of q0 is equal to k. It has reached k basically. So, or it is yeah, it has reached k. So what we have to simply do, we have to first pop the first element, because first element is popped because the next element which is coming, that is anyways outside the window of the already existing 3, maximum 3. So that is the reason we pop 1. Now interesting thing is, once even the 1 is popped, even then the initial index of q, whatever is present at the start, index present at the start of q, even that thing contains the maximum element. You see the beauty of this, it still has the maximum element. So that's why we are popping anything that is smaller, like the coming index is, let's say, 4. Anything, any index that is present in q and having a lesser value in nums, that is being popped out, because we want that the start of the index in the queue must always be the greatest one. So since we saw that the element 4 was coming here, with index 4 was coming here, and 1 is outside the window of 4, so we popped 4. Now we checked whether 5 is greater than the previous element -3. Yeah, it is greater than that, so we simply pop 3. Okay, let me put my laptop in charging. Yeah. So we pop out 3 from this because minus 3 is smaller than 5. We see minus 1 is also smaller than 5, so we also pop out 2. We pop out both of them and we append the index of 5, 4 over here. Okay. So, and one more thing, when we saw 3, so since now I was greater than k minus 1, we have already seen written this condition if I is greater than k minus 1. So we have to append the element at the index in the starting of queue. In the starting of the queue, at that time 1 was there. So again, in the in this window we'll add 3. So basically what does that mean? That in the first window the maximum was 3, it is added here. In the second window the maximum was 3, it is added here. Now in the third window this 3 is out of scope because it doesn't lie in the window itself. And minus 1 and minus 3 are subtracted or are popped out of q because they are smaller than 5. And so at the start of q again the index which is present is 4, and this is the maximum. This will contain the maximum element in this window, and it is 5, so we add 5. Now 3 comes 5. Since 3 is smaller than 5, we simply add its index in q. And but still at the start of the queue we have index 4, so we go and see at the index 4 we have the value 5, we add 5. So after I has reached k minus 1, this is something to be noted. After I has reached k minus 1, every time for every I we have to take from the starting of the queue, we have to see which index is present in the starting of the queue. We have to pop it and put the value into answer. That is what will be forming our answer. And then we see 6 coming in. When 6 came we saw 3 is smaller, 5 is smaller, so we'll basically omit 5 and 4 both, and we'll append the index of 6. 6 is appended over here. And again 6, since it is the starting of the queue, now again it is the starting of the queue, so it will contain the maximum element. So maximum element it will contain is 6, so 6 will be appended over here. Similarly when 7 comes, 6 is omitted and 7 is now at the starting of the queue, so 7 is the greatest element, so 7 will be appended over here. So if we go to the answer, so this is the approach which will give fetch us the answer, because you will see that we are not uh, running some nested loop. There is no n into k type of thing, it is just in the order of n. So this was basically meeting the time complexity criterias. And there's one more thing, like we are not just omitting if it is greater, like if the coming element is greater than the last element, like let's say minus, we had right minus 1, minus 3, 5, 3. So when 5 was coming, these two were omitted from q, the index of these two were omitted from q. But even if instead of minus 3 it was 5, even if the values are equal, even in that case we have to omit it. Because basically what we will be doing is, we have to, if the values are equal, we have to take the latest 5, right, latest 5, so that the it remains for the longer period of time, it remains in the window. So if, like, let's say there were 2 5 somewhere in the list, so we take this 5 so that this 5 remains for longer period, this remains in the window. Since having this or having this doesn't make a difference, but choosing the second one will make sure that this 5 remains for the longer duration, it remains in the window. So that's why even when we see 5 over 5, if previous one is smaller, then to anyways we remove its index from the queue. But even if it is equal, then also we remove its index from the queue. So that's what I've implemented over here. The code won't get that complex, the code is easy. Yeah, but the fact that we had to understand this was a little tricky and it took me some time. Please go through this video again. If it is not understandable, please rewatch it. I have made sure that I cover what exactly is the logic behind this, but yeah, I understand that it gets a little complicated, so please rewatch it. Make sure to like, subscribe. Thanks a lot for following up till here. Keep coding, and yep, happy weekend.